Alright, so for this section, we're going to solve equations. They involve exponential functions, they involve logarithms. So it's basically just how to handle all that. I don't know if y'all have like actually done this for real or if y'all just did InSolve before. Yeah. I don't either, so I don't use it because you don't need to use it. Y'all are too smart. Yeah.
Oh, wow.
But we're not going to use that because you're better than that. And if I need to take away your calculators, I will, so that you can just do this all by hand.
You don't want to do that, please.
Okay, so, yeah, we're just going to go at it how you should. So here, if you've got a number out front, how can we rewrite that? What do we just say we do with numbers in front? That's your exponent. So this is like log base 5 of x squared equals log base 5 of 9. Are we all right with that? So essentially, if you've got the same thing going on here, log base 5 of something equals log base 5 of something, does it not make sense that the inside parts must equal each other? Right, so technically there's like a way that you can work through this to cancel out those logs. So if you give everything a base of 5, then y'all remember that property that we talked about Friday where if you have like 5 log to log base 5, does that make sense? They cancel each other out. So that's why we're able to do what we're getting ready to do here. I don't feel like y'all care that much, so we're just going to go ahead and set these guys equal to each other. Okay, so x squared equals 9. So what must x equal? Could it be positive and negative 3? Are you sure? Can you have a negative inside of a log? It's just 3, because negatives are not part of your domain for log functions, correct? So if you get negative answers on any of these, will that work? No, so you're going to have to throw that one out. Is that okay? All right, cool. So questions so far, are we all right? Okay, so looking at the next one. How could we condense these two since they're being added? What could you do? Multiply. So you're going to multiply x plus 6 times x plus 2. What do you have to use to do that? The box. When you do that, you end up with x squared plus 8x plus 12 equals 1. And so before how I was saying, if you give everything a base of 5, that would make like the log cancel out. So we can do that here, or you can kind of do like the around the world thing. Either way, it's going to work. So I don't know what makes more sense to y'all. Do you know what I mean by the around the world thing? Where we said like this to this exponent equals that. Are we rewriting those a long time ago? Or you can just give everything a base of 5. I think that's a little bit easier, so that's what I'm going to show here. So if you give everything a base of 5, these cancel out. You've just got x squared plus 8x plus 12 equals 5 to the first power is just 5. Is that okay? So maybe. Okay. So what should we do from there to try to solve this? Minus 5. Then what do you do? Do what? We need a factor? Yeah. To x plus 7 and x plus 1? Factors of 7 that add to be 8? Did you say 4?
7 to 1.
Where did I hear 4? I am losing it. I really thought you said 4, like twice. That's why I was like, what? I was way confused. My bad. I just couldn't hear you. So x equals negative 7 and x equals negative 1. So both of those are negative this time, but if we plug them back in, because we've got other stuff going on up here, so if you plug in a negative 7 plus 6, is that still going to be negative? Yes, then negative 7 plus 2, will that still be negative? Yes, so will negative 7 work? No. So let's check negative 1 as well. So if we plug in a negative 1 plus 6, is that still negative? What about negative 1 plus 2? No. So what's our answer? Negative 1. Is that all right? Questions? Do what? When you plug it back in here, you won't have negatives inside the log, which is what we're trying to avoid. Okay? Does that make any sense? So on this one, if you put a negative 3 right there, you have a negative 3 in the log, and that's not okay. Correct. Correct. You can't have negatives in the log. All right. So any other questions? Okay. So moving on to number 3. We need to condense that first. So since they're being added, what can we do? Multiply. So we'll have natural log of x times x minus 4 equals natural log of x plus 6. So since we have natural log of something equals natural log of something else, the natural logs kind of just cancel each other out. And again, you can get everything a base of e this time, and that would make those go away as well. That's why we're able to just set the insides equal to each other. So that's going to give you x squared minus 4x equals x plus 6. What should we do from there? Yeah, get everything on the same side, and then we're going to try to factor. So we've got x squared minus 5x minus 6. What will that factor into? Factors of 6 that subtract to be 5. 6 and 1. Is that all right? So then x equals 6 and x equals negative 1. So if we plug in a 6, positive 6 right there is going to be okay. We have 6 minus 4, that's still positive, so that's fine. And then 6 plus 6 will still be positive, so we're good there. No. Because the first sign, you always keep second sign here. Means that these have to be opposite signs. So if you did negative 2, negative 3, that wouldn't multiply out to be negative 6 over here. Does that make sense? Yeah, okay. If we plug in a negative 1, you're going to have negative 1 inside your natural log, and is that okay? No, so throw out the negative 1, your only answer is 6. Questions? Is this like super confusing? Okay. So for number 4, this one's really not bad at all. We're going to do the around the world. So we're going to say log base 2 of equals. Is that okay? And type that into your calculator. You're going to get what x is. So we type in log base 2 of 5. Do you want to go 2 decimal places? That's what I did. So we got 2 point what? 2.32. Is that all right? You're just typing that straight in the calculator. Questions? All right, so number 5 is much of the same thing. What do you think we need to do first, though? We could try to get the bases the same, but we've got 3 as a base over here, and then but it's 8 times 3 to x. Then we have a 5 on the other side, so I'm not seeing anything that's going to be the same really quickly. Do y'all see anything that's jumping out to you that's going to be the same? No. What do you have to do before you can do around the world? No. Divide by 8 first. And then you can do around the world. So we'll say log base 3 of what? 5 over 8 equals x. And then you'll type that straight in your calculator. And you'll have your x value. So you just got to make sure that whatever your base is like by itself first before you do the around the world thing. That's all that one's showing you. What do we get? .43. Is that all right? Questions? Okay, so for number 6, this one's a little bit different. So we've got 2 different bases. We have 5 and 3. Is there any way that we could rewrite those so that they would be the same base? No. So now I've got to start thinking, what can you do to get those exponents or get those variables out of your exponent? Because we can't handle, like we can't do anything when you have variables in your exponents, right? There's no way to solve that. So is there a way to move your exponent out of the exponent? Can you do an x minus 2 root of something? Does that work? No. Think about our properties from Friday. What did we do up here? How did we go from here to here? You just move it. That's a property of logs, right? So if it's a log of something, you can move your exponent to the front, right? Natural logs are the same thing, yeah? So I'm just going to use natural log because it's easier to write. So we're going to take the natural log of each side. So natural log here, natural log here. So when you do that, you can pull that exponent to the front. So that's now x minus 2 times the natural log of 5 equals 3x plus 2 times the natural log of 3. Is that okay? So if you've ever got variables in your exponents and you need to solve and you can't rewrite your bases, then you need to take the natural log or a log of each side so that you can pull those exponents to the front. Is that okay? All right, so from here, we're going to want to get the x's by themselves first. So I think it would be helpful to go ahead and distribute so that we can get those x terms like separate. Does that make sense? So we're going to do x times natural log of 5 minus 2 times natural log of 5. And same thing on the other side. We'll do 3x times natural log of 3 and 2 times natural log of 3. Feeling you. Hey. Right. I can get stuff after second block. Thanks. We all right with that said? Okay, so what are we thinking from here? It's not really going to help us because that would just undo what we just did. We're trying to solve for x, right? So would it be helpful to get your x's on the same side? Yeah, let's do that. So I'm going to move this guy over and I'm going to move that guy over there. I forgot to write the x right here.
I was wondering about that.
3x natural log. I just dropped him. Alright, so thoughts? Do you have any? What are we solving for again? Did both of these have an x?
Yeah.
Can we pull an x out? Then how do we get x by itself? Just divide by all that stuff you don't want. And you can type that straight into your calculator, and that'll give us our answer for x. Questions on that one? So we're okay? Alright, so when you type that in, what do you get? Yep, I get 3.21. For these two, since they are both exponential functions, you can have negative exponents, so that's why we don't have to like go back and check our answers like we did with all the logs up top. Yeah. So we're good with negative 3.21, and that's it. Any other questions on this one at all? So we're good to go there? Alright, so looking at number 7. This one's a little tricky. So we've got 4 to the x minus 2 to the x minus 12 to the x. So what are our thoughts? We can't pull out a 2 because it's like your base here. So we can't pull stuff out of the base. Could we rewrite so that we have the same bases? At least for some of them? How could you rewrite 4? So it's going to be 2 to the 2x, right? So I'm going to write it like this. I'm going to do 2 to the x squared. Is that okay? Is that okay? So then we've got minus 2 to the x minus 12. So from here, what does that kind of look like? If you have something squared minus something minus a constant. It's kind of like a quadratic, right? So that's how we want to go about solving it. So is this like confusing to look at and makes your head hurt at all? A little bit? So let's do this instead. Let's say let u equal 2 to the x. So this is called u substitution, and you're going to use it in calculus when you get there. And it's just a way to rewrite equations to make them a little bit easier to solve. So we could instead say that this is just u squared minus u minus 12. And that's a lot easier to look at and factor, right? Because we don't have all the other stuff in the way. So how would you factor that out? That okay? So we could say u equals 4 and u equals negative 3. But really, what was u? Two to the x, so we'll say 2 to the x equals 4, and 2 to the x equals negative 3. So will 2 to any exponent ever give you negative 3? So we can throw that one out completely. That's not going to give us an answer that works. And then 2 to what power would give you 4? 2, so x equals 2. Questions? Alrighty, so the last one that we've got x plus e to the x equals 2, and let's use a calculator for that. So the easiest way to do that is to type in this as a function, type in 2 as a function, see where they intersect. You could also move the 2 over and then plug it in and find your zeros. Either way there will work. Which way do you want to do? Intersection or zeros? Zeros, I think those are easier. If you've got a lot of stuff on either side, then it'll be easier to do an intersection point because you don't have to worry about solving. But this one's easy to just minus 2 over, and then that'll give you your 0. So again, either way will be fine. So I'm going to type in x plus e to the x minus 2 because we're solving, and we'll just see where our 0 is here. So menu, analyze graph, choosing our 0. And it's at 0.443. So if we did that the other way, I'm going to go to a new graph for it just to show you that it still works the same. We've got x plus e to the x. And then for your second equation, we'll type in 2 because that's what it equals. And then just see where they intersect. So if it's on the left, maybe, if it is click, there we go. And it's still the same point, 0.443. Is that okay? Questions on this? Alrighty, so that's all we got for notes today. So I'm going to give you homework and you can start practicing.